Hi, my name is Manish Gupta, and in this video, I'm going to talk about LNAI's OLMo model. So let's get started. OLMo stands for Open Language Model. In fact, the main reason why LNAI has proposed this model is that they wanted to have a truly open source language model, such that they have basically made sure that they have made available the training code, the evaluation code, checkpoints, and the logs, training logs. So all of that stuff is basically made completely openly available. Okay, so the claim is that several other models are actually open language models in that senses, but in some cases, training data is not, or other pre-training data is not completely shared. In some cases, some other things are missing, but in this case, they've sort of made sure that everything is available openly and publicly. From an architecture perspective, well, OLMo is just a decoder-only transformer with some popular things like it has no biases, it has Swiglu activation function, it has rotary position embeddings. But an unusual thing is basically this layer norm. So they have non-parametric layer norm compared to other models, which basically use RMS norm like Llama 2 or parametric layer norms like OpenLM 7 billion or Falcon or Palm 8 billion models. Okay. So if you compare, their model checkpoints, well, they basically train two different size of models, 1 billion and 7 billion in size. 1 million model has 16 layers, 7 billion has 32 layers. The 1 billion model is trained on 2 trillion tokens. The 32 layer 7 billion model is trained on 2.46 trillion tokens. So that's that. The other interesting thing is that, yes, the vocabulary, so the tokenizer is basically a BPE based tokenizer from GPT NeoX, and it has a vocabulary size of about 50K. Okay, so there are other statistics about the model architecture, which I mentioned here in comparison with Llama 2, OpenLM, Falcon, and Palm. So for example, the number of heads, almost 7 billion uses the same number of heads, 32 as Llama 2 model. Um, Also, the dimensions is 4096. The dimensions for 1 billion checkpoint is 2048, but for 7 billion, it is 4096. And that's practically that. There are, of course, other things. For example, sequence length. So it can basically accept 2K sequence length. So it's not really good for long sequences. Okay. All models have been trained on this dataset that is called as DOLMA dataset. Now, DOLMA is basically a diverse multi-source corpus taken from 7 different data sources with 3 trillion tokens and 5 billion documents. In fact, the 7 different sources are mentioned here: Common Crawl, the Stack, C4, Reddit, and so on. And as you see, it is diverse because it actually contains the documents like web pages, code, social media documents, STEM papers, so scientific papers, books, encyclopedia, and so on. Right. So essentially, it's overall 5 billion documents covering about 3 trillion tokens. OLMo model, once it is pre-trained, it's actually fine-tuned, instruction fine-tuned, using OpenInstruct Tulu dataset. So that's that. And then it is actually further aligned with to follow human instructions with the distilled preference data using DPO. So that's basically the architecture and the training recipe for OLMo. Okay. So how does OLMo perform? Well, I mean, the performance of OLMo is not as such very awesome compared to several existing models. But the best part, it is an open model and it performs as good as other publicly available open models. Maybe not as good compared to the most recent ones, but it is almost as good as, let's say, Llama 2. Okay. So here is a comparison of the 7 billion checkpoint with several benchmark data sets, right? And they have compared it with Falcon, Llama, Llama 2, MPT, Pythia, and so on, right? And what you observe is that the 69.3 average that OLMo obtains is basically very close to many of these models, especially Llama 2, which is like 70.5, so a point more. Maybe it's better to say it's comparable to Llama rather than Llama 2. So Llama 2 is slightly better in that sense. And note that this is all zero-shot evaluation on these tasks. Now, they also present comparisons of the instruction-tuned model. So if you compare the OLMo-based model with OLMo plus supervised fine-tuning and OLMo plus supervised fine-tuning plus DPO. The interesting part is that instruction tuning improves the performance and safety of OLMo. So essentially, the performance is measured using MMLU zero shot evaluation and alpaca eval percentage win evaluation. The safety is actually measured using these two datasets, Toxigen and Truthful QA. Higher scores on everything is expected except for Toxigen, where lower scores are better. Okay. So as you observe, almost 28.3 on MMLU, but with the supervised fine-tuning and DPO, the scores increase significantly. Right. Similarly, if you observe from a safety perspective, well, Toxigen almost performance is 81.4, but it basically improves significantly with a major reduction in toxicity when you do supervised fine-tuning and DPO. Truthful QA accuracy, of course, improves with SFT and DPO. Now, again, if you sort of compare it with, let's say, the Tulu 2 model, again, coming from LNAI itself, well, I mean, Tulu 2 is actually better. However, compared to the pre-trained OLMo, the supervised fine-tuned and DPO, aligned OLMo models are better. So in summary, in this video, I talked about this OLMo model from LNAI, stands for Open Language Model. And it is called Open Language Model mainly because checkpoints, dataset, logs, pre-training data, right? Instruction fine-tuned data, training code, evaluation code, everything is available publicly. It's a decoder-only architecture with the standard, architectural considerations that people typically use these days. Okay, and it has comparable performance with some of the current decoder-only models like Llama. Okay, but yeah, I mean, when you compare performance with Llama 2 or Llama 3 and so on, it's not as performant. But the good part is that yes, there are all of these things publicly available. Okay, that's it for this video. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.